The broadcast is now starting. All attendees are in listen-only mode.
Welcome. This is Shannon Mayette, Marketing Manager for the Wi-Sun Alliance. Thank you for joining today's webinar, Comparing IoT Technologies. Please note this webinar is being recorded and will be made available on the Wi-Sun website for future reference. Following the presentation, there will be time to address questions. If you have a question, please use the question box on the right-hand side of the screen. Questions will be read by our moderator and addressed by our speakers. At this time, I'd like to turn it over to our moderator, Marina Donovan, Vice President of Marketing for Itron and the Marketing Chair for the Wi-Sun Alliance. Marina?
Thank you, Shannon, and welcome everyone. Today's speakers are Phil Beecher, our CEO and President of Wi-Sun Alliance, and we also have Alex Davies, who is the founding editor and main contributor of Rethink IoT, a news and analysis service, and he has been at Rethink Technology Research for 6 years. He has particular interest in LPWANs and new networking technology, focusing on the technology itself, not only doing that, but also with a keen eye on the business case and practicalities. So welcome, gentlemen.
Yeah, good morning.
Morning, Marina.
Good morning or good afternoon, depending on where you are, or evening. So today's discussion is around the new white paper that was released yesterday, and it's comparing IoT technologies at a glance, and it discusses how Wi-Sun FAN compares with LoRaWAN and NB-IoT. As we all know, there's a plethora of choices for wireless connectivity, ranging from private networks you can deploy yourself using Wi-Sun-based technology to fully managed services from network operators. The wireless protocols themselves all differ significantly, but the three that are most applicable to utility, smart city, and industrial IoT are Wi-Sun field area networks, LoRaWAN, and NB-IoT. You'll be able to download the paper on wisun.org. It is available now. And in order to help bring the paper to life, we thought it would be useful to have a dialogue around the key topic areas. And so I have a set of questions from the different speakers, and as we're having a dialogue between us, feel free to submit your questions in the question box. So my first question is, what are the key characteristics of the three main IoT networking technologies, including the difference between mesh and star topologies? Alex, do you want to tackle that first?
Sure. So there's overlap between them all, and LoRaWAN and CAT-NB both have the sort of conventional star layout. There's a central base station, and all the devices are connecting to the base station. And once the network traffic is at the base station, it will backhaul to your sort of cloud applications. And you build out your network by building more base stations. Wi-Sun FAN is quite different. It's a mesh protocol, and some of you will have come across Z-Wave and Zigbee for sort of personal area networks. But as the name implies, FAN, field area, is much longer range. And the nice thing about the mesh approach is that you get multiple sort of redundant pathways back to your applications, your command and control systems. And that's the sort of big difference in topology. The other difference is in the type of spectrum that they use. So LTE Cat NB is something that I always refer to as a licensed LPWAN. So it's using licensed spectrum like your sort of conventional LTE networks. And LoRaWAN and Wi-Sun FAN are using unlicensed spectrum. They vary slightly depending on market, but that helps keep the cost down because there isn't a $1 billion spectrum license fee to recoup. So that I think is the main kind of key characteristics between them. And depending on your application, making blanket statements about power usage and battery life is a little redundant. But I like what I see from Weisun on that front. Phil, is there anything I might have missed there?
Well, I think I'd like to accentuate a bit more of the difference between the mesh and the star topology, particularly, and as you mentioned, as you want to expand a network using a star topology, you need to deploy more base stations. One of the advantages that mesh has over a star topology is in terms of coverage, not just in range, but in difficult to get to places. So for example, where you might have devices in a basement or in a culvert under the ground, so things like water and gas meters are sometimes accessible underground, then the range becomes a problem. So unless you're deploying a large number of base stations, it helps to be able to have 1 or 2 hops of the mesh network. Another advantage with mesh is that as you build the network, as the density increases, then with features such as adaptive power control for the devices, you can get much better coverage and less interference. So as a result, the resilience of the network grows and the reliability grows.
Phil, what can you tell us about certification or just around the standards and things like that?
Yeah, so Weisun as a technology, and for those of you that have been following the history of this, you'll know it was based on an open standard from IEEE 802, which was originally 802.15 4G. The reason why standards are so important is that it lets everybody in the ecosystem, which we'll talk about a bit more later, get benefits of multiple vendors. So from product vendors, for example, we have silicon that supports the Weisun field area network from 6 or 7 different silicon vendors. In terms of product vendors, that gives them choice on where they buy their radios, and then they can produce products which the customers can then have a choice of. So open standards make it very easy for multiple companies to compete evenly and equitably in the environment. So that sort of overcomes that fear of vendor lock-in. But open standards are not synonymous with interoperability, and that's something that is often misunderstood. So just because a product is standards-based, it doesn't mean that it's going to interoperate with another product that's actually based on the same standards. So I think those two things are worth identifying, that they're actually, interoperability is something that you need open standards for, but open standards don't guarantee interoperability.
Right. Alex, did you want to add to that?
Yeah. So I like to think about sort of the worst case kind of scenario and sort of barriers to sort of adoption and deployment. And on the licensed LPWAN side of things, the coverage has always been reliant upon the local mobile network operators choosing to upgrade their sort of radio access network and core network and build out these sort of sales channels. And in terms of a motivator, a lot of the initial IoT use cases were they were quite low value until they're sort of mass market. They're very large volume propositions. So the mobile network operators have broadly been quite slow to build out, and they're also very shy about telling you actual sort of coverage and propagation figures, which leads to, if you have an IoT use case and sort of smart grid and utility metering is one of the strongest, it leads you to a decision on whether you want to wait for a public network operator or if you want to deploy a sort of private network, one that you own or you pay someone to run for your sole use. And if you've decided that the local MNO has been too slow, or it's not providing the right sort of objectives or sort of SLAs, you can go the private network route. And in the Wi-Sun ecosystem, having multiple choices at every single kind of stage in terms of from the chips in the end devices all the way up the sort of networking stack to the sort of the cloud and application side of things, that makes the fear of vendor lock-in quite small, because you've got that kind of rich platform to sort of build on, and it's not something that's as dependable in the sort of the license side of things, and it's something I think you have to be aware of in terms of making these sort of big, very valuable but very complex decisions. You need to be sort of sure that if one company goes bust, you've got backup options.
Great.
Okay.
And I think,
Sorry, Marina.
Go ahead, and I've got another question for you.
Yeah, can I pick up on something that Alex said just there, because he mentioned the fact that if you're using the mobile network operators to provide the service, then you have to wait for them to deploy the network. There's also the other end of the lifetime of the product. Typically, utility industry is looking for 10, 15-year lifetimes. And as people are aware, the technology of the mobile networks tends to change very rapidly. So it's quite possible that in 10 years' time, the NB-IoT option will not be delivering the profit that the mobile network operators want from it. So they get rid of the service, which is going to leave the utility company who's been relying on it for another 5 years after that, with a dilemma of how they provide the future service. Using a private network such as Wi-Sun gives you control over the whole lifetime of the network.
And you'll begin to see those issues crop up as the MNOs start sunsetting the 2G spectrum and then 3G. That's on the horizon. But yeah, very, very good point, Phil.
Which brings another thing about open standards, because I quite like to use the analogy of Wi-Fi here. Wi-Fi is appropriate for office environments and everybody uses it and it just works. And it has been working consistently for a decade now or longer. And as new developments are introduced in Wi-Fi technology, things just work faster. But you as the user don't notice that difference. Now, Wi-Fi isn't applicable for these large outdoor networks, but the method of evolution of standards means that as technology develops for field area networks, Wi-Sun can embrace that technology and make sure that we don't orphan devices out there. We just evolve the technology and maintain backward compatibility. So that's an important feature as well.
Absolutely. And Phil, you had talked earlier about just because it's based on an open standard doesn't mean that it's interoperable. Do you want to talk a little bit about the FAN certification program? I've got a
certainly.
slide here.
So a little bit of, many of the audience will have heard this before, but I'll probably reiterate a little bit of the history of this is that the utility industry, going back about 10 years, wanted to start deploying wireless mesh networks for smart meter networks. And as a result, a standard was developed, 802.15.4G, which was just the radio standard. During that development process, and part of the standards process in general is one ends up with lots of different options in a standard, some of which are useful, some of which aren't. Also with 802.15.4G, it's purely a radio technology. It doesn't describe how the routing in the network works, how the security works, etc. So within Wi-Sun Alliance, we have basically taken a number of different open standards from different organizations such as IEEE and IETF, the Internet Engineering Task Force, and we've taken mandatory features from each of those standards that provide a recipe, if you will, of how a product should behave. So if you take if you have a recipe from a recipe book, if everybody makes it the same way, then you should end up with the same outcome. So what we've done with Wi-Sun is create what we call technical profile specifications that take different functionality from each of the different standards, and then we create a fairly rigorous testing program, a certification test program that allows multiple vendors to test their products against this certification program, and hence you're basically as close as possible guaranteeing interoperability between those products. As I mentioned earlier, we're looking at not just radio, but module, final products, and that such as smart meters or street lights, etc. And different parts of that vendor chain can always have a choice between who they purchase from. So that's about building a whole ecosystem. And then as a result of all of this, each party down that chain has less risk. As Alex mentioned, if a company goes out of business or stops producing a chip, then it's possible for the product vendor to do a redesign but still maintain the product. So there's less risk. They don't have to change everything. As I said, we're based on open standards, and standards evolve. And the other thing that Wi-Sun does is we do our test programs in two parts. So there's a conformance part, which proves that the products are conform with the standards and the profiles which we've developed. But then we have an interoperability part, which after a product's proved its conformance, we test it that it's interoperable with other products out in the field. So that means that there's an end user can integrate new products into an existing network with confidence. I think one of the things that you see in the utility industry as well is, it's a very large investment for people to make. They often want to run a pilot because they're concerned about, whether the equipment's going to behave as it should do. When you're using interoperable products based on certified products, then that means that there are other installations that customers can look at that show that this stuff is working properly as well. So therefore, your time to market can be quicker.
Great, thank you, Phil. Let's take a look at our next question. And I am seeing some questions come in on in the question window. So for those of you listening, feel free to start populating that. So next topic is around security. I mean, I cannot read anything today, any publication that is not talking about security, a security breach, the concerns with IoT and security. And so clearly huge concern, number one concern for many of our customers. But what role does the networking technology play? And what are we doing to address this? And Bill, do you want to talk about Wi-Sun's approach?
Yep, I'll start with Wi-Sun, then I'll probably pass over to Alex to talk about the other technologies. So with Wi-Sun FAN, we started on the premise that we needed very high degree of security, enterprise level security, because typically the networks are used in critical infrastructure applications. So therefore, every device on the network includes a certificate. We're using standards-based certificate security. So for those that like acronyms and numbers. Each device on the network has an X509 certificate. We're using a transport mechanism for security called EAP-TLS, which is extensively used on the internet. And we provide mutual authentication of devices when they first join the network. So that means that if a device isn't what it says it is, then it can't even join the network and can't do the key exchange at the beginning. And also, if the network isn't the network that the device believes it should be, then the device won't try and join that network. So that's the basic description. Alex, do you want to talk?
And sure. So the sort of short answer is that in CAT-NB and LoRaWAN, there's no two instances that use the same security architecture. On the CAT-NB side of things, you're reliant upon the mobile network operator keeping things up to date, properly protecting messages in transit, storing data securely. That's another big one. We spot open AWS buckets quite frequently. And in LoRaWAN, there are sort of standardized ways of doing things, but LoRaWAN isn't quite the same in terms of being an open standard as the Wi-Fi fan. But I think it's fair to say that there isn't a single protocol here that you could pick on for being insecure. That would definitely be wrong to say. But I do feel that the Wi-Fi ecosystem it's been doing this longer. It's got more experience than the others, and just having a scroll through the member list of the Wi-Fi Alliance, there's some sort of pretty notable names in there. And then sort of for the IoT as a whole, these LPWAN technologies are almost shiny examples compared to some of the consumer facing technologies, the Wi-Fi and Bluetooth based stuff that's in a race to the bottom in the sort of smart home market is just a glaring example of what happens when you skimp on security, in that you have hard-coded credentials that can be hacked if anyone was interested. But the problem there is that if you're an actual hacker, there's no money in breaking into someone's smart home ecosystem via their light bulbs. But if you were to extrapolate that out to the sort of utility and critical infrastructure markets, you'd be on the hook and facing serious criminal repercussions if you as a utility provider were rolling this out in the way that we see it in the smart home. So on the whole, the LPWAN space is in a good place.
Okay, thank you, gentlemen. And there's more information available in the white paper for our listeners. Let's take a look at the next question. This is about a healthy ecosystem, and we've talked a lot about this in terms of just the members of Wi-SUN and what they're doing for interoperability. But Phil, do you want to talk about why a healthy ecosystem is important to the success of a networking standard?
Yeah, so I guess I'll probably reiterate some of what I've already said. But I think it starts at the beginning where you're looking at the devices and the availability of devices. So the very fact that we have a number of major silicon vendors who are delivering interoperable radio chips is a good starting point. Investment in developing RF chips is pretty substantial. So when you have a large number of or a fair number of companies doing it, they're looking at getting a reasonable revenue back, but it brings the prices down as well. So you can buy Wi-Fi radio chips pretty cheaply now. The other part of this is in terms of equipment vendors. So we see without mentioning any of our member companies, you'll see quite a few competitors in the smart meter market space, also in the module market space. So that gives choice to new companies that are developing products. There's also the ecosystem of firmware stack developers and software developers. One of the things that I guess we haven't touched on is, why some field area network, the actual technology is quite sophisticated, so the development time for a protocol stack can, there's a fair amount of effort in doing it. So therefore, if a product vendor can go to another company and license an existing stack in one way or another, then that's helpful for that. We're seeing a number of companies that are providing value-added services such as testing and test tools for all of this. And it just makes everything much more accessible. So it means that a small company can come along, they've got a great idea for something like a line sensor for the utilities, but they don't have to develop the whole communications protocol stack. They can go to one of a number of companies and get a communications module that they can integrate with their own product.
Absolutely. I mean, I think you raised a really good point. A lot of developers out there don't have to deal with the whole network protocol stack. They can just, build to what's already been done. That's great. Alex, anything you want to add to that?
I think it would be touching on things we said before, really, in terms of maturity and your availability of choice. And in the YSUN sector, at least, I think it's fair to say that it's more focused on a specific application in terms of this kind of smart grid and utility kind of focus, whereas the other two have really struggled for quite a few years to nail down the sort of key use cases, of which smart grid and utility is one. But there was talk for years that asset tracking would be one of them, and that's really not panned out, and that's the issue. I think that's probably worthy of a separate webinar, but it's in the YSUN ecosystem, things just look a bit more focused on the sort of specific task at hand. And it's not to say that YSUN is sort of stuck or anything. There's a huge opportunity in kind of smart city applications building off YSUN platforms, but it seems more focused from my perspective, and that's definitely a good thing.
Great. Okay, let's go to the next question. How can initial investments in IoT be maximized? And there's been a lot of talk about backward compatibility, and that's a key influencing factor when choosing a network. Alex, do you want to take that first?
Sure. So I can talk through a sort of an example where a utility is mandated by a local regulator to provide smart metering, and evaluates technologies, hires a few consultants, and decides to pick, say, CAT-NB, and they plan their roadmap. They start using developer kits. They get their heads around it, and they're building up to the deployment, and suddenly the LTE network that they were promised, the upgrades, are being pushed back because the MNO isn't going to make enough money per base station. So they've looked at their return on investment, and there's no motivation there. So in that example, you're stuck. You're reliant on the MNO to deploy for you. If you were in LoRaWAN, it could be similar. You might find that a company that said they were going to deploy a network has to pull out, or it's a startup, it's run out of money, the investors got cold feet. And sure, you could try to deploy the network yourself, but suddenly this utility is gone from looking at just doing sort of maybe the metering and contracting for the other parts, and now you're asking it to become a mobile network operator. And I think a lot of utilities would shy away from that. But if you were to have sort of focused on YSUN at the beginning of that journey, you knew what you were getting into ahead of time, that the roadmap was a lot clearer, and you can be as beholden to other providers as you like. You could do everything in-house. You could own the entire stack, or you can sort of tap into this sort of rich ecosystem of providers, and that means you can get the best kind of value because you can bid them against each other. And in terms of backwards compatibility, when you deploy one of these networks, you have to think of it as a foundation, and you're going to be building on top of it. And as I mentioned just before in the smart city opportunity, if you're asked by a local council, a city, if they could use this foundation for some other business application, that's a huge potential revenue opportunity that you couldn't really tap into if you were trying to run it off a public network provider. So that's one of the benefits of having some sort of private network, in that you're kind of the ruler. You get the final say, and whether that means sending more engineers out to sort of configure software, or it means asking your systems integrator to spool up a bit more capacity. That flexibility is there, and it's not something that you're guaranteed to have if you've decided to go with LTE or a LoRa public network. So that's another sort of tangential and kind of expansionist business opportunity, and it's something that you can sort of really see cropping up more frequently in the near future, at least. And it's why your kind of initial investment has to be quite carefully considered, because if you'd be daft to leave that money on the table if it appeared in your sort of pipeline. And I think that YSUN is a really nice way to sort of keep the options open while having like a really focused primary application.
Excellent. Phil, anything to add to that?
No, I think we'll touch on something a bit further on in the discussion, and I did mention previously that technology moves on, and the advantage of standards-based devices and having that large ecosystem is that you don't do step changes. There's always an evolutionary process, which is useful for backward compatibility.
Okay, great. We are wrapping it up, and I'm seeing some questions coming in, so I'm excited to get to those. So in the paper, we highlight several case studies, including a spotlight on the City of London. And we'll be coming out with a video very soon that will, with Giles Radford and the City of London. And Phil, you've spent some time with Giles and learning about what they're doing to accommodate and move people around the City of London with the streetlight projects. Would you like to elaborate?
Yeah, certainly. And as you said, people can find out more information later on. But I think as far as the City of London was concerned, they were looking at upgrading streetlights, providing LED lighting, which gave them better reliability, but also more flexibility in managing light levels and controlling lighting for things like public safety, for example. And they decided to choose a YSUN compatible network. The installation was justified on the business case purely for street lighting. Using a mesh network means that they have very good connectivity, reliability, and resilience. So that there aren't street lights that can't communicate because of their physical location. Those of you that know the city, there's quite a lot of narrow streets and high rise there, so it's quite an interesting physical environment. So they installed street lighting using a wireless mesh. But something that we haven't mentioned so far, but we've touched on, is YSUN is a multi-service network. So what we're actually providing within YSUN is an IPv6 network canopy, which can be well provided by the streetlights, that allows one to connect in other devices. So for example, one of the things they were looking at is traffic flow, pollution monitoring, looking at areas that they may be worthwhile pedestrianizing to, basically increase the businesses that are going on there. And having this sort of network means that they can add new sensors onto the network, either temporarily. So if you're looking at traffic flow because you're looking at maybe changing the way the traffic signals work, or even pedestrianizing, then you can put temporary sensors in. But also other things like parking monitoring and other occupancy sensing. So those sorts of things. I think they've got something like 12,000 lights being deployed over a period of 2 years.
Great. So we are wrapping up, and I'm seeing some questions come in, which is really great. But I think that there are some. Did you have another comment, Phil?
Well, no, I'd like to address, there's 2 comments that I can see that I think are specific about Wi-SUN. So shall I go ahead and address those?
Well, I think let's do the key takeaways first, and then we'll get to the questions. And I think I always like to summarize these just with, what are the key takeaways? And Alex, I believe you're really passionate about this topic. Do you want to kick us off, and then we'll hear from Phil, and then Phil, maybe you could address some of the questions that we've been getting.
Sure, I'll just rattle through these. In terms of key takeaways and where the market is right now, the Internet of Things is here, but it is not the panacea that you were probably told it would be. It's a very valuable business tool, but it's this evolutionary trend. It's not a revolution, and to that end, the total cost of ownership is kind of your biggest concern and sort of consideration. You have to be very aware of how one of your sort of applications ties into the rest, and you can become very beholden to what you thought was a small decision made a long time ago. It can really come back to bite you, which is partly it's vendor lock-in, but also it's being cynical and thinking through like what's the worst case scenario, and open standards are a good way to sort of avoid that. So yeah, the sort of key kind of Wi-SUN takeaways is that it's a very versatile tool. It can be what you want, sort of at any kind of level, and that ecosystem is mature. It's vibrant. There's a lot of companies involved, so you should have quite an easy time of keeping your application running. And its mesh architecture is very beneficial when it comes to pushing updates. There are some very impressive demonstrations out there of pushing firmware updates to meters through a citywide network, and the mesh function is something that really sets Wi-SUN apart from the other approaches, and it's very powerful. So no, Phil, I think I'll just hand that over to you now to jump into those comments.
Right. Well, I think you've done a pretty good job covering them there. Actually, it's
good to hear.
And so, but just adding a few things, and you touched on this as well. With the Wi-SUN architecture, really reflects the architecture of the internet, but for large-scale outdoor IoT. So the design of the internet initially was done in such a way that it would be very reliable and very resilient and resistant to hacking, and would be flexible and adaptable. Now, obviously, using wireless technology rather than wired, you provide, you increase the vulnerability to a certain extent. But what we've done with Wi-SUN is come up with a lot of mechanisms to mitigate against that vulnerability. I think with Wi-SUN FAN, if you look at completely private owned or there are a number of companies now that maybe were originally primarily focused on providing total solutions, hardware and software solutions, that are now focusing on providing the infrastructure and the management of the infrastructure. Because we're using the same protocols and same technologies, the internet, it means that the scalability network management is well proven. As Alex mentioned, pushing over-the-air updates is pretty straightforward in a YSUN environment, and very reliable as well, unlike some other environments. And you will need over-the-air upgrades, both to fix security vulnerabilities. Also, some of the applications are pretty sophisticated, so there may well be bug fixes required. And it's also increasing functionality as well. So we're seeing more and more edge computing type applications sitting on the IoT, which means therefore that you're going to need to put applications out to the edge, and having a mechanism and a good communications network that can do that is very important to maintain that backward compatibility and that upgradability.
Well said, Phil. Well, I do see a number of questions, and so I feel like there's a couple that I think are kind of aligned together, but I think the first question that came in was about hybriding YSUN and PLC, and you had mentioned that YSUN works with multiple types of communication technologies. Would you like to address that one first?
Yeah, so specifically with YSUN and PLC, YSUN Alliance established a liaison agreement with HomePlug Forum, which was a similar organization focused on PLC. We did that several years ago. Initially together, and then after HomePlug Forum stopped operating, we took it upon ourselves in YSUN. So we have a specification within YSUN that describes exactly how to hybrid YSUN FAN and 1901.2 PLC using the same networking and routing protocols and security on both. So there's a spec to do that. And if people are interested in going ahead with that sort of thing, then they can just let us know, send an email to info@YSUN, and we can provide more information.
Okay, info@YSUN, is it WI-SUN?
Yes,
Okay.
WI-SUN.org.
Org, right. Okay, and then there was a question here. Where can I find the YSUN specification?
Okay, so the YSUN spec is currently available to members on the website. So you will initially need to become a member of YSUN to get hold of the spec.
Right, and there are different levels of membership, right? And some, yeah. So if I'm somebody that just wants to test the waters, do I have to make a big investment? What does it look like to become a member?
Oh no,
I just want to got to be informed.
It's a pretty small investment initially. I mean, and this is picking up again on what we were talking about ecosystem. One of the things that we really want to do in YSUN is to make it accessible for new companies to come in and enter the market and look at developing products or looking at deployments. So pretty easy entry point. Again, specific questions, please send us an email.
Right. And then there was a question on, can you talk about roaming capabilities / roadmap for YSUN?
There have actually been there has been some work done by certain academic and testing institutions on roaming, or whether one would call it roaming in the cellular sense. Certainly nomadic operation is something that is being looked at. It wasn't in our original design brief, but it appears that it is something that people are looking at. So, it's not something we're directly working on within the Alliance.
Okay, well, I imagine it would depend on what our customers and members want to do with that as well.
Yep. Yep, exactly. I mean, so, and that's worth pointing out again that, you know, we have a pretty large organization. I think there's around 250 member companies now. We have regular technical calls as well as marketing calls. So member companies of contributor membership or higher basically get to set the agenda of what we do and what we do next. The testing part of this is pretty rigorous, but we now have quite a few utility companies that are involved in setting the specifications. So in other words, they're rather than relying on the product vendors to deliver what the product vendors think that the customer wants, you can have end users getting involved. So we welcome that as well.
Okay, great. There were a couple specific questions on just this technology. So one of them is leaf mode included in the current spec?
So short answer to that is we have not included leaf mode in the certification program at the moment, and it is on the roadmap for the next step. So as people are probably aware, so the current specification, the current certification program deals with the devices that form the mesh and not the end devices that are sitting as leaf nodes on the mesh. Now that doesn't mean that you can't integrate leaf node devices, and obviously a number of our member companies are already doing that because that's the way you integrate low power sensors and devices like water and gas meters onto the network. But at the moment, we don't have a certification program for it, but we will do in the not too distant future.
Okay, and there was another question about what is the role of OFDM in Wi-SUN's forward-looking strategy?
Okay, so this takes us back to the 802.15.4G efforts and other activity in 802. OFDM is a different modulation system that allows you to achieve higher data rates. We again have already done a specific, or we have captured in our market requirements the need for OFDM. OFDM will become particularly useful in integration of distribution automation, where you're looking at higher data rates and lower latency connections. So we know we need it. There are specifications already available for the technology that so the way the modulation works, the channelization, etc., which has already been approved by standards bodies, and Wi-SUN will integrate that into a future version of the Wi-SUN fan specification, maintaining backward compatibility as well.
Okay, great. We had just another question come in about Wi-SUN Alliance and DLMS protocol for application layer. I know Wi-SUN has been working with DLMS. Do you want to elaborate on that?
Yep, there is. So Wi-SUN Alliance has another liaison agreement with the DLMS User Association. There is a specification for running and configuring Wi-SUN networks and using DLMS over Wi-SUN. That is currently in draft form. I believe a second revision of that is due for circulation within the DLMS User Association fairly soon. So it's actually not, it wasn't a particularly difficult task to do because as Wi-SUN is open standards based using IPv6, a lot of the work has already been done within DLMS User Association for running DLMS over Wi-SUN.
Okay, great. And then there was a question about, even though we've been talking about this, but why choose LoRa over Wi-SUN over LoRa? Why would you do that? And maybe Alex wants to take that one.
Yeah, so I mean, my answer for any IoT business case would depend on your sort of total cost of ownership. If you're a utility provider or you're involved in that ecosystem, I would wager that your TCO is going to be quite a lot lower with the Wi-SUN options because of the ecosystem. You know, the companies that you already buy equipment from are the ones that are involved in the Wi-SUN Alliance, and that's not such it's not such the case in the LoRa ecosystem. You can do metering with LoRa, certainly. There's no technical reason why you can't. You just have to sort of evaluate it from where you are now. And for a lot of these applications, they're not greenfield. They're sort of retrofit, and you're trying to fit these in with existing business processes. So for utility ecosystem sort of decision makers, I would wager that it would be an easier path with less friction if you pursued Wi-SUN than LoRaWAN. But there are so many variables at play that to make such like a blanket statement can be tricky. So yeah, it's very much dependent on your sort of your environment.
Can I jump in there? So
Yes, jump in.
Obviously, I'm promoting Wi-SUN here, but I would say one of the areas where Wi-SUN does win out here is because you're looking at already with our existing specifications, you're looking at higher data rates and peer-to-peer connectivity. As Alex mentioned before, when you have something like LoRaWAN, where you're looking at a tower-based solution, then all communication goes through that tower. So there are circumstances where you could see something like a single point of failure, which is not going to happen with a Wi-SUN network. It means that when you're looking at some of the utility use cases, such as outage management or restoration, then where you will benefit from peer-to-peer communication, Wi-SUN can provide that, whereas LoRaWAN cannot necessarily do so.
Right, it gets back to that use case.
Yeah, so for pure meter reading, as Alex said, I mean, LoRaWAN is probably suitable, and I know that there's been work, promotion of LoRaWAN in water and gas, for example. But then if you start looking at other use cases, where maybe you're looking at leakage detection, where you maybe want higher data rates, more frequent meter readings, then Wi-SUN becomes an applicable technology.
Yeah, it's nicely aligned for like actually smart grid applications rather than just connected grid applications.
Yep.
Good point. I see, I'm going to take one last question before we wrap up. If we see this in terms of the OSI model, how does Wi-SUN fit, or what standards are using that are different than the OSI layers?
Okay, so Wi-SUN addresses layers 1 to 4 of the OSI model. So we define the operation of the physical layer, the medium access control layer, the networking architecture, up to the point where you would look at connecting through either UDP, TCP, or CoAP. We also describe the security architecture that sits on the side of that. So basically all the way up to key exchange. So device authentication and key exchange. And as I mentioned before, the specifications we're using come from IEEE 802, so it's not just 802.15, but there's 802.1x. There's a key management protocol that was described that is basically 802.11i over 802.15. There's a huge number of IETF specifications that we're using, so 6LoWPAN, and then ICMPv6, DHCPv6. I think the simplest thing for all of this is there is actually a shorter overview of the Wi-SUN plan spec that is publicly available. So we can probably make that available after this link for those that want to go into the technology.
Right. Well, Phil, thank you, and Alex, thank you, and thank you to all of our listeners today. Great questions, and I think it's not here, but we did get a question about will the recording be available, and the answer is yes, it will be available today. And I think, as Phil, if you mentioned earlier, if people have specific questions, they should just email info@wi-sun.org, and then they can get the information they need. So thank you all for your participation, and hope you have a good rest of the day.
Thank you.
Cheers, everyone.
Thank you.